The reciprocal functions and their graphs. The unit circle is the circle centered at the origin with a radius of 1 unit. Its equation is given by x squared plus y squared equals 1. For any point xy on the unit circle, the first coordinate x equals cosine t, and the second coordinate y equals sine t, where t is the standard arc on the unit circle from 1, 0, terminating at xy. Note, t is measured in radians. The circular functions sine, cosine, and tangent functions have been defined using the unit circle as a motivating idea. We now consider the functions called secant, cosecant, and cotangent. The secant function is defined to be the reciprocal of the cosine function. So BC, this line here, equals secant t, which is 1 over cosine t. The cosecant function is defined to be the reciprocal of the sine function. AC, this line here, equals cosecant t, or 1 over sine t. The cotangent function is defined to be the reciprocal of the tangent function. So AT up here is the reciprocal of tangent. Cotangent t equals 1 over tan t. Secant and the unit circle. The properties of similar triangles allow us to see the relationship between the cosine and secant values. Here we have two triangles. Triangle RQC is similar to triangle BPC. RQ is to CQ is to CR as BP is to CP is to CB. So we have sine t is to cosine t is to 1, as tan t is to 1 is to secant t. So therefore, cosine t divided by 1 equals 1 divided by secant t, or equivalently, cosine t times secant t is 1, or secant t equals 1 over cosine t. Because triangle BPC is a right triangle, the Pythagorean theorem results in an important identity. Tan t squared plus 1, because this side here is a 1 squared, equals secant t squared. If cosine t equals a over b, then secant t equals b over a. Because of this, the cosine and secant functions are positive for the same set of arguments t, and similarly negative for the same arguments. The table to the left provides some sample values. Cosine of 0 is 1, and secant of 0 is also 1. Cosine pi over 6 is the square root of 3 over 2. The secant of pi over 6 is 2 over the square root of 3, which can be then written as 2 times the square root of 3 over 3. So you just flip them over. They're reciprocals. And cosine pi over 2 is 0. Secant of pi over 2 is undefined, since if you have 0 over 1 here, and then this would be 1 over 0, which is undefined. Cosecant and the unit circle. The properties of similar triangles allow us to discover the relationship between the sine and cosecant values. Triangle RQC is similar to triangle CTA. RQ is to CQ is to CR as CT is to TA is to CA. Therefore, sine t is to cosine t is to 1, as 1 is to cotangent t is to cosecant t. Therefore, sine t over 1 equals 1 over cosecant t, or equivalently, sine t times cosecant t equals 1, and cosecant t equals 1 over sine t. Because triangle CTA is a right triangle, the Pythagorean theorem results in another identity. Cotangent squared t plus 1 equals cosecant squared t. If sine t equals a over b, then cosecant t equals b over a. Because of this, the sine and cosecant functions are positive for the same set of arguments t and, similarly, negative for the same arguments. The table to the left provides some examples. Sine 0 equals 0 over 1. Therefore, cosecant 0 is undefined because that would be 1 over 0. So you can see that they're just reciprocals. Sine pi over 6 is 1 over 2. Therefore, cosecant pi over 6 is 2 over 1, and so on. If you have internet, click on the hyperlink below for a Desmos demonstration of cosine and secant. Here are the graphs of cosine and secant in the first quadrant. The colored dots correspond to points on the cosine curve and its corresponding reciprocal points on the secant curve. So here is the cosine wave. It starts up here at 0, 1, and then goes down to a minimum down here at pi. And the secant wave goes up like that. The graphs of cosine and secant for one cycle. What is the domain of secant t? What is the range of secant t? If you have internet, click on the hyperlink below for a Desmos demonstration of sine and cosecant. The graphs of sine and cosecant in the first quadrant. The colored dots correspond to points on the sine curve and its corresponding companion points on the cosecant curve. The graphs of sine and cosecant for one cycle. What is the domain of cosecant t? What is the range of cosecant t? Well, the domain is going to be all real numbers except for where these asymptotes are, at 0, pi, 2 pi, and so on. The range is going to be all real numbers that are between negative infinity up to negative 1, and then from 1 up to positive infinity. The tangent ratio given by tan t is the ratio of sine t to cosine t. Tan t equals sine t over cosine t. For any point xy on the unit circle, the slope of the radius from 0, 0 to xy is given by m sub r, which equals tan t, where t is the measure of the arc on the unit circle from 1, 0, terminating at xy. Note t is measured in radians. The cotangent ratio given by cotangent t is the ratio of cosine t to sine t. It follows that cotangent t is the reciprocal of tan t. Cotangent t equals cosine t over sine t, which is equal to 1 over tangent t. Triangle BPC is similar to triangle CTA. Therefore, BP is to PC is to BC as CT is to TA is to CA. So tangent t is to 1 is to secant x, as 1 is to cotangent t is to cosecant x. You could also say tangent t over 1 equals 1 over cotangent t. You can show that they are reciprocals in these ways. The period of the cotangent function is pi. One uninterrupted cycle occurs between 0 and pi, and a second uninterrupted cycle occurs between pi and 2 pi. The cotangent graph is asymptotic at x equals pi k for integer values of k.